Hello, welcome to this week 5 of the BSc course on data science, the big data module. So, till week 4, we've actually been spending time talking about the different types of data, how PySpark comes into play, what are the different paradigms which are the underlying foundations for PySpark. Spark in general, of course, but also PySpark. We now start to look at the common data processing patterns that will most likely be encountered in practice in almost any enterprise setting. It has been referred to in different forms by different people. Some set of companies or technologists swear by it. Some firmly believe that these patterns no longer make sense in the shape and form that they originally were conceived of, and some of this has to be reinvented. I'm of the view that the patterns themselves are time tested. They raise questions and they solve those questions in a manner that is required for any data processing steps, any data processing problem statements to tackle. But the tooling, right, and the way that you go about solving for those can actually change based on the technology available, the sophistication that's at your disposal. So, without further ado, let's begin this week's topic. It's called as ETL or ELT, based on who you talk to. One of these two terms gets bandied about as being important. What is ETL? ETL stands for extract, transform, and load. It also coincidentally refers to a series of technologies that have come about over the last 30 years, maybe 25 years, and became increasingly popular 15 years ago, after which there was kind of like a bad reputation attached to it, that it was not conducive for big data, and as a result, some of the tools and the technologies in this category, they evolved and they had to stay ahead of the game by inventing features related to big data. Some of them didn't. But whatever said and done, the purpose of ETL is beyond just those tools or the category of technologies. So let's understand what ETL itself is about, and that's what we will actually focus on in this lecture. So, extract, transform, load, the acronym is what forms as ETL. In a classical sense, ETL used to be this dedicated software, that still is actually in some cases, to control what happens when data moves from a transaction system like an OLTP into an analytical system or a warehouse or a data mart or a data lake. In general, I'm just going to refer to that as an OLAP system. OLAP again refers to that spectrum of OLAP that we looked at in week 3. Right? So, OLTP for us would be anything that's a database or an API or an event stream. Again, I'm just generalizing the notion of a transaction system as OLTP. So, the ETL software used to run on its own machine. Right? That's what I'm referring to when I use this icon of a monitor. And that used to sit separately from the OLTP system and also separately from the OLAP system. And it used to kind of be the via media through which data would flow, and it would eventually make its way to the OLAP system. Why is it necessary for the data to flow through the ETL machine? That's a good question. That's how the initial set of ETL tools were designed, and as a result, some of the bad reputation is because of that. But since then, the tools in this space have become more and more sophisticated. So much so, nowadays, if you really think about the function of ETL, it is to control the job of the ETL, not to actually be the bottleneck in terms of data transfer. So think of it as the machine sits here, makes extraction requests at the OLTP system. Once those requests are successful, the data starts flowing directly over the network to the OLAP system. While the data flows through, there is transformation that's applied. The transformation applies in the machine. So in that context, if transformations are applied, then that data flows through the transformations and comes out to the pipe and then goes back to the OLAP system. The L refers to the load of that data, transformed data typically, in some cases direct data. Of that data, the load is getting actually done in the OLAP system. ETL refers to these three things converging together, but in many cases, the job of extraction is really a function of what the OLTP system is and what kind of tools or technologies it supports for the extraction. So it's beyond just the ETL tool itself. It's actually a dependent very critically on the OLTP system. Likewise, on the other end of the pipeline, the load into the OLAP system is dependent critically on the functionalities of the OLAP system, what does it provide, etc. As an example, some of the OLAP systems allow you to do what's called as bulk load, and bulk load is typically faster in case you have large volumes of data that you want to put in. So, the ability for the ETL pipeline to use bulk load capability, which is very specific to the OLAP system, is what is allured to, right, by having the L be very close to the OLAP. You get the picture. Now, the transformations that happen in the classical definition of ETL happens in this machine, and like I said, the data just flows through, gets transformed, flows back. So, in a sense, the transformations are getting centralized, and as a result, this has some advantages and disadvantages. We'll take a look at some of the disadvantages later on, but the advantage from the perspective of tooling was that you had effectively one system to control exactly how data was getting transformed. And in that system, you can put in all kinds of governance structures around what are standard processing patterns, standard data changes that I support as a company, and have that centralized system be responsible for all of the eventual forms of data that's getting analyzed for business purposes. So that was a good piece when things were started out. Again, we should go back to this time when OLAP was farmed out, especially data warehousing, which is one of the first instances of a platform in the OLAP spectrum. When data warehouse was justified back in the day, it was set up as the need for a single source of truth, which cuts across all different types of OLTP systems, and which also provides a centralized view of the different things that those OLTP systems are talking about. If you just have one OLTP system, you don't really need a data warehouse. But if you have multiple, and each of them was talking about the same thing in different ways, then the data warehouse became like an important piece of technology. And to populate the warehouse, it wasn't just a case of dumping data here and putting data there. You needed to actually use a standard set of transformations. You needed to actually answer a standard set of questions, right? And we will take a look at those questions a little later in this slide, in these lectures. And as a result, the centralization of transformations went hand in hand with the centralization of the data for warehousing purposes. So that's the context in which we should look at this. So why would different OLTP systems, have different versions of the truth? It could be the case because as a company, you've evolved over a period of time, and the version 1 of the software was responsible for collecting, for instance, user information up to a certain point. And then version 2 was set up in a completely different system. It overlapped with the version 1 for about 9 months because we didn't want to really sunset the version 1, and then version 2 picked up. Or you acquire another company, the other company always had their own systems, so now it's time to integrate. Or it could be the case that you generally have different businesses, and each business has its own, like, mantra for doing things, and you don't want to touch that, but you still need a common business-centric view of what all is happening across the entire company. In which case, you have multiple instances of those users and their records, so that you can bring it all together. Why did I pick on the example of users? Because that's one of the most glaring examples of why a centralized platform to merge those different ways of representing the same user is justified. So we'll take some concrete examples into it. Alright, so that's ETL. What are the different patterns? Sorry, the animation is a bit off. So the first pattern that's there is called as load to staging. So first and foremost, what are these patterns? The patterns are a way for us to understand what are the common data transformations, common data activities, right, that we need to think about, that need to be standardized. And having done so, having standardized these, you're likely to actually be able to solve a plethora of data-related problems in your enterprise, irrespective of tooling or technology. Right? You could code up this entire thing in PySpark and you'll be good to go. Or you could use a proprietary tool like a classic ETL tool. That's fine too. Right? It doesn't matter what tool you use, but what matters more is these patterns will come again and again and again in some shape or form. So it's best that people become accustomed to them. Yeah, so load to staging is a very common pattern. So what does staging really mean? If you take a look at a standard OLAP platform, let's say data warehouse, it's one of the most classical ones. I'm going to continue with data warehouse as the example of the OLAP platform, but a lot of what I'm saying here is applicable for other OLAP technologies, that's like the lakehouse, etc. So the layer that gets the data for the first time from the various sources, that is what is conventionally referred to as staging. It's called as staging because that layer is not meant to be permanent. It's meant to be a temporary stage on which you assemble a bunch of these different source data sets as they are, and then you run like a downstream ETL process to get to a integrated view of that same data. It's the integrated view of the data that constitutes the core functionality of the warehouse. So remember, we were saying the warehouse is a silly version of truth. We took a look at this description back in week 3 as well. That integrated layer of data is the one that's actually giving us a silly version of truth. So the way that integration will happen is that staging is a data layer. Think of it as like the analogy in the world of a city would be staging is a colony, right? And in this colony, you have people from all over India coming in and being temporarily, housed here, each coming to their own state and mingling only with their own sets of people that they are familiar with, that have come together along with themselves. Right? So those are the different types of households and streets which are there. In the integrated colony, the people from the different states or the places where they come from, they started to co-mingle, and not only that, they started to set up, communities together. They started to bring their different cultures. The cultures have become unified. They started to bring their best practices, and that started to become unified. So, in the integrated township, everything looks homogeneous because there's a mix of heterogeneity in everything. Right? There is a standardization to how services get accessed, right? How different people get called, what are the ways in which they are addressed, what are the ID cards that they use, and all of that stuff, right? So there's a planned mechanism to how this integrated layer gets set up. The functional view is what happens when a specific function, a specific line of business wants to come in and take a look at the integrated set of data. And when they want to do that, they also want to get some standard views on top of it. Views meaning they want to get some standard aggregations, standard matrices, KPIs, formulas, whatever you want to think about as. So, in the world of enterprises, like one of the standard functional views that get asked for all the time from a warehouse is the finance functional view, meaning the finance function in the company, they want to understand what is the current profit and loss, what is the total number of loans taken, loans given, total volume of business, and how much of it is on credit, how much was what is the discount, and all kinds of money related matters. So when finance asks that question, notice that they could have actually answered those questions by going directly to the staging layer, but then they would have had to do two things. First, they would have had to go and look at each of the different lines of businesses and their data sources individually, and as a result, they would have had to understand how does that business actually store its data, and then ask those questions. The second and most crucial aspect here is they also have to then interpret how to actually compute a certain metric. So the metric could be what is the cost of acquisition of new customers. Right? That's something that finance is interested in. But the measurement of cost of acquisition could be very different from one business to another. Like an e-commerce business has a very low cost of acquisition. The physical businesses, the ones that are advertising through public media, print media, the ones which have sales agents deployed within the stores, right? Those kinds of physical stores, those kinds of physical businesses have a very high cost of acquisition, relatively speaking. So finance needs to come in and then start to think about how to measure cost of acquisition, and then go and implement it. And they'll implement it in different ways in different businesses. But what could happen is the way that business leader, or the way the marketing team, the way the sales team looks at the same cost of acquisition could be different, because they genuinely believe that their businesses are unique and the formula that's standard doesn't apply. So they calculate it in a different way, or they plan the entire thing in a completely different fashion, and it's not right to use this kind of definition. So in which case, business will start to consume their own data from staging and report some number. Let's say the cost of acquisition they report as 1,000 rupees per online customer. But the finance function, when they start to look at the staging data, they report their own cost of acquisition as 10,000 rupees. So what is right? So the CEO then looks at both these numbers and says, are you guys, are you both really that mad to tell me that both these numbers are right? But the reality is that if you understand the context from where both of them come from, he or she is actually doing exactly what they think is right. So they're not wrong. The CEO is also not wrong in asking why is there no consistency. The answer, as it turns out, is the fact that there is no integrated view of how something that is subjective needs to be interpreted. Yeah, so here's what I think, as an aside, I want to just share this point of view, right? We all like to think about data as something which is very black or white, right? There's a very clear interpretation for data. We like to think about data as having the structure, be relational, be JSON, whatever. But there is this binary sense of data, and that makes us believe that there really cannot be two ways of looking at the same data. But that can't be any more wrong than using the same analogy of people, right? So you can't just look at a person and judge and say that this person is this or this person is that. That would be the wrong thing to do, and that would not be fair. That would not be giving benefit of doubt to the subjectivity that can come in when people actually do things, and when you only look at the surface, you don't look at what happens inside, what happens with what's the context of how something is happening, what's the context of a behavior pattern, all of that. So very similar, right? Data actually has that context, and that context is far more important at times than what the data is saying in bits and bytes. So this example of this finance calculating a metric, which is very different from how the business calculates, is a good example. And that's not because the data is telling different things. It's because data being put together has very different interpretations based on who looks at it. So the integrated layer then becomes the crucial way to address that problem, because then it's one view of what all is happening in the business, one way to define customer acquisition costs that everybody can agree upon, right? And therefore one metric to the board, which makes it easy for the CEO to take some positions. So yeah, that's the integrated view. The other angle to the other advantage to integrated view is that integrated layer rather is that the task of interpreting data, the task of working with the data from the source, its columns, its values, etc. All of that is now done once per source, so that every single function that wants something from it doesn't have to go through that same exercise again and again. So the function, for instance, finance, the cost of acquisition is a very specific number, but even before the cost of acquisition, there is this amount column that needs to be interpreted. They don't need to go about understanding what are the different ways amounts can come in. They just look at amount column and says, yeah, okay, all the businesses standardized, so I know exactly what amount means now. But the creator of the integrated layer would have actually gone through the process of, looking at different instances of amount, and she would have made sure that those instances all agree on a standard layer which it's represented. Including things like currency, and decimal precisions, all kinds of things, like simple technical things all the way through business requirements. So the next pattern that is very common in ETL is, of course, transformations. T stands for transformations, but what kinds of transformations? So the first here is the most common thing that you do when you have multiple data sets is actually joining them. So when you join staging tables, you need to be able to, of course, do different types of joins, like equal joins, in joins, left out the joins, fill out the joins, etc. We'll take a look at these things in the SQL course rather than the SQL lecture coming up in one of the subsequent weeks. So joins are critical. Formulaic computations, these are standard patterns that you would have to get access to. So think about all the different Python, data manipulation functions that you might get from pandas and NumPy and things like string functions, which are just native Python functions, or how do you compute standard deviation with percentiles, or how do you compute the length of a sentence, right? How do you break down a large text into its constituent elements of names, addresses, and phone numbers. So all of those are actually different types of formulaic computations if you really think about it. So transformations which are allowing you to plug and play different libraries of these standard formulas basically is necessary. Right? That's part of the ETL pattern. The third one is, of course, at times all you need is just no formulas, just directly mapping from source to table or source to destination. With that kind of a setup, you just do direct column mapping. Say column A here means column amount will be part with table. So in effect, you would have different transformations be represented as arrows like this. So direct column mappings coming from any source, any staging table. So notice that the tables on the left, we call them the source tables. The source tables would be coming from multiple different domains, like multiple different lines of businesses, multiple different OLTP systems. But the target here is usually some kind of an intermediate table, en route to an integrated layer table, or the final integrated layer table itself. So in which case, what we're really doing in these transformations is picking up data from multiple source tables across domains potentially and bringing it all together. And when we bring it all together, we need access to these kinds of standard transformations, like the joins that's depicted here, direct column mapping, and some of it is indirect through formulas. Like all of this is what we need typically. So when you choose a technology for ETL, make sure that you get these flexibilities in play. And it sounds so, obvious when you state it like this, but then you'll be surprised, right, at some of the choices that people make when ETL gets chosen. You do have a lack of flexibility in some of the technologies that you might see in the market. Alright, so before we go to keys processing, I'll just